In this video, we're going to be going through how to cut a turning part using the BobCAM for SOLIDWORKS. So here's our part, and I've already gone in and set up a coordinate system on the front to tell it which direction X and Z is sitting in so that everything comes out properly. Now to get started, I just want to right click on CAM defaults and go down to New Job. Now inside of here I could choose Turning, and then I'm going to use my BC2X lathe. It should be the only lathe that's in here because the important thing for this one isn't so much the machine, it's the post-processor. And then after I pick the machine, I'm going to make sure the Start Stock Wizard is checked, and then I'm just going to hit OK, and that's going to launch the Stock Wizard. So then for the workpiece, I'm going to go ahead and pick the solid model that represents the final finished part, and then hit the next arrow right here. And then I get a choice of setting up my stock. So I can use either cylindrical stock or revolved stock. Now revolved stock would mean I have a shape that's drawn out usually as a sketch, and I'm going to revolve that shape to match. So I just want to make sure to go in, click on the cylindrical stock type, and then I could choose my coordinate system. So I'm just going to pick that coordinate system. It automatically orients with the X and the Z in the correct position. And then right here I could tell it the diameter of the stock. So I'm going to say it's 2.5 inches. The ID is going to be 0. I don't want a hole through this part. There is no hole, but if you were starting with a job that had a hole in it already, you could tell it what the hole diameter is right here in the middle. And then right here is the total length. So if I look at this, I could just tell it that I want to make it 3.5 inches. So I have something that I'm going to cut off later on. Now right here for the stock origin, this is how much in front of this origin, basically what we want to face off. So however much we want to face off, I'm going to say let's just face off 100 thousandths, and then I could hit the next arrow here. Now right here we get to set up our machine setup, which is again going to be this coordinate system here. So we have 100 thousandths that we're going to face off, and then we're going to cut back. Right here for the clearance on the front face, we're going to be at 1 inch. So if we do any rapid moves, it's going to be 1 inch in front of the part. For the OD, it's going to be 1 inch outside the part. And if we're doing anything on the ID, it's going to be at 50 thou by default. Now when I'm done, I can go ahead and hit OK. And then I'm just going to right click on the word stock and say blank unblank. Now when you're going in here, you still have your full material library. So you could set up your materials. But when you're setting up normal turning tools like CNMGs and VNMGs, it's not actually using those tools for the feeds and speeds. You're still going to enter in your constant surface speed. When you do your drilling, it will actually calculate feeds and speeds for you. So I just want to go up to the turning tools and right click here and go down to tool crib. And I'm just going to go add a few tools into the tool crib. Now when it comes to drilling, it's up to you whether you set those up. I always like to at least set up the center drill, but having a drill added in that matches the drill size is not a bad idea as well. So I'm going to start by going here to the roughing for the lathe, and I'm going to add from the tool library. And I'm going to go ahead and pick this CNMG with a 64th rad and an 80-degree diamond. So I'm going to pick that and then hit OK. Now for my finisher, I'm going to go to the finish section, say add from tool library, and this one's going to be a 64th VNMG. So I'm going to select that and then hit OK. Now after that second tool's in, I'm now going to go set up the tool that I need for my groove. So that's just going to be a groove, and then I'll add from the tool library. There's no difference between the rough and the finish on this one. I'm going to go with the 1/8 inch wide with a 64th rad OD groove, and then hit OK. So there's my grooving tool there. And then I want to add in a center drill and a drill. Again, if you decide to, you don't have to, because when you define the whole thing, it'll pick tools automatically, but I want to make sure they're in the right place. So I'm going to go ahead and click on center drill, say add from the library. And on this one, I'm just going to choose my number 5 center drill and hit OK. And then right here, I can go down to my drill, and this one's going to be a 1/4 inch drill. So I'm going to add from the tool library. So I could choose by my diameter. I'm just going to drag that right up into the drag column header up here so it breaks it down. And then I could just scroll through and find myself my 0.25 tool, so right here. And then I could go ahead and pick either my 1/4 inch drill or my E drill. So I'm going to pick my 1/4 inch and then hit OK. And then the last tool we need to add in is a cutoff. So I'm just going to go to cutoff, add from the tool library, and all I have is this 3.25 length 1/8 inch wide cutoff. So I'm going to pick that one, and there is the tool right there. Now when I'm all done setting up the tool crib, I'm just going to hit OK, and then I could start my actual toolpath. So I'm going to start by right clicking on machine setup 1, and I'm going to take care of the 100 thousandths that I added onto the face. So I'm going to say lathe end face, and then for my geometry, I don't actually need to pick anything. I'm just going to hit next. It's automatically going to know where to cut to based on the stock that's in front of the part. So right here for my rapid plane, I have it at 200 thousandths in front of the part. That's where we're going to rapid. Because I chose the facing feature, it knows that we're working off the front face, and it's going to use region 1, so from the top down. If we wanted to go from the center out, we could just do region 2. So I'm going to bring it back to 1. Right here for the constraints, we either have from stock or custom. From stock is going to have BobCAM look at the amount of stock, both the diameter and the amount sticking out. So the 100 thousandths and the diameter, and it's going to make sure we cut the entire section. We could also go in with custom and we could tell it how far back to cut, and it'll add in toolpaths based on that without reading any of the model. Now right here we have some extensions which allow me to extend the start and extend the end of the cut. So in this case, if I wanted to have it start in position a little bit above the part, I could say let's make this an extra 1/8 inch tall. And when I go past the center, I want to go past it by a 1/16 of an inch. That way I get rid of any little tit that's going to be left on the front of the part. When I'm done with the extensions, I could just hit next. Right here for the machining strategy, I get a choice of either doing a rough or a rough and a finish pass. So if I wanted both the rough and the finish, I'd choose the rough and the finish. In this case, I'm just going to run it with the end mill rough and then hit next. Right here, we have our choice of separate moves or CAN cycles. And this is all just going to depend on your post processor and whether or not these CAN cycles have all been set up. So I'm going to go with separate moves. Next, I then have my roughing tool. So it should pick my CNMG. It's tool number 1. If I click show tool holder, I could see it right there. Now we could change this tool here on the fly. We have our reference point here off either the corner, the tip of the tool, or the center. We could also change the shape of the tool. So we could tell it it's a 80-degree diamond, a 55, a 75-degree diamond, an 86-degree diamond. We even have the 35-degree diamond down here. We have round tools, square tools, triangles, and trigons. And then you could choose your clearance. So basically, you're just trying to match the codes for whenever you purchase your inserts and your holders. So in this case, I have a CNMG. I'm just going to line it up with that. So you have your tolerance here, your type here, and then your nose radius here. Now, if I uncheck the holder and I see a bigger view of the insert, we also have the inscribed circle diameter, which is if you were to draw a circle that touched all 4 sides of this insert, that would be the inscribed circle diameter. So if you have smaller inserts, you could drop this down to say a 1/4 inch or even 3/8. So you have a smaller insert and it'll just be a little bit smaller to hopefully be able to reach into these areas a little bit better. Right here for our tool orientation, I'm going to turn the holder back on. We can see orientation 1 is standard. Orientation 2 is flipped. So this would be trying to face off either the backside or have a tool coming from kind of the backside this way. We could also say orientation number 3. So you'd be doing more of an ID cut, and an orientation number 4. Now, when you go from horizontal to vertical, that's where you really get the ID cutting tools. So this is the orientation you'd want to be in to go down the center of a cut, right down the middle of the part, and make your cut on the way back out, or however you decide to cut it. So I'm going to go with vertical, and I'm going to leave it on orientation number 1. You can also add a custom angle, and then right down here we have our tool number, and then our offset register. So if we needed to modify this to give it different offsets, we just check this button and enter in our tool offset. And then right here we choose the spindle direction of clockwise or counterclockwise. As well as down here we have our coolant type of flood, mist, air, oil, or we could turn it off. Now right here for feeds and speeds, we get the choice of either going with an RPM or a constant surface speed. So you're going to set up your maximum RPM, your surface footage per minute, and your feed rate. Next, we then have the patterns page. Now, a lot of these patterns you're going to see again when we do the turning, when we actually rough this part out. This is just going to do a face pass. So I really wouldn't use anything too crazy. I'd probably go with a standard pattern because it's going to start at the beginning, cut the face, move in however many times I tell it to do it. But we do have the ability to also do an offset. So offset basically lets us cut the shape out of the pocket, kind of work that shape in, but it doesn't always have a consistent depth of cut. If all I do is chip this little section out here, well, I might have a pretty heavy depth of cut on the next one. Your sorting allows you to also do a zigzag. So a standard is always going to go back to the beginning of the cut, like a zig move. It's going to go back to the beginning and then make a cut. If we say zigzag, it's going to zigzag its way down that cut. So I'm going to leave it with standard and standard for the patterns. Over here we have our compensation. Now we have 3 forms of compensation when it comes to system compensation. So off is no compensation. We're not looking at the tool or the holder. We're just following the path with the point on the tool. Now, if we turn it on without collision detection, it's going to run a little bit better. It'll be closer to the result you're looking for, but the back of the holder might drag along the part. We also have on with collision detection, and we can even tell it to use the tool holder. Now, this does make it calculate a little bit longer, but as long as you're defining your tools properly, we're going in and making sure those tools aren't rubbing on the part. Now, you also have the ability to add in a G41 or a G42 for machine compensation. Primarily, you're going to use that with system compensation off, and then just use either a G41 or a 42 depending on your cut. Next, again, I have my parameters. Now, this is a roughing pass, so all roughing passes are always trying to set it up for a finish pass. So we have our depth of cut. This is how much we're going to take off per pass. And then right here under the finish allowance, we'll see that there's 10 thousandths being left for a finish tool to clean up. You could also leave rough allowance to come back in with another rough pass. So in this case, because I'm not running the finish pass, I'm just going to zero out the allowance for the finish. And then right here we have our overlaps. Now again, this is a face cut, so I don't really have to worry about too many overlaps, but we do have the ability to go to the previous cut. So we could say no overlap. This is where we would normally end, right there. When we go to the previous cut, it doesn't end in the same spot where it looked like before. It's actually going to extend past and then lead out after. So you're actually cleaning up some of these steps that you might be putting in the part as you're roughing it in. You could also tell it a custom overlap distance, but in my case, I'm just going to go with no overlap. Right here, we have a choice of doing a sharp corner or a round corner. And this isn't really changing how the corner looks. It's more so how do we interpolate that corner? Do we kind of roll it over with a round move, or do we make a sharper kind of angled move? And then right here, we have an option called trim to stock, where we're able to bring in another model of stock, basically kind of like another revolved model of stock, and tell it exactly where it needs to cut. From here, I'm just going to hit next. And right here, we have our rapids. So for the approach, we could tell it the default rapid approach. So start from the default, come in and make the cut. We could also tell it to go to the OD or ID clearance as well as the face clearance. And we could even define a point to start at. And for the approach, I usually leave it on a default rapid approach. That works out pretty good. On the exit, if I'm just doing OD work, the default rapid on exit's fine. The only thing I have to worry about is the home position. But I also have the ability to tell it to go to the tool home, and then we have specific movements. X-Z means it's going to go home using X first and then Z. Z then X means it's going to use Z first and then move in the X. So sometimes you have to make sure on your ID cuts, you're not accidentally going and leaving through the part. You're going to want to make sure to leave through the Z and then out the X. So when you see Z-X or X-Z, it means that axis before the other. When you see this one here where it says ZX, that's an angle out. And you want to make sure you don't accidentally pick that when you're doing an ID job, because the tool will just leave right out through the center of the part. So you could send it to the tool home, you could send it to the cycle start, or you could send it to a defined point. You could also just say no rapid on exit. Now, once again, because I'm just doing OD work, I'm just going to say default rapid on exit should be just fine. I'll hit next again. I have my leads, and I like to leave the defaults. A parallel lead in is going to line me up above the part, and then it's going to start a little bit higher because I already even have the extensions, and then a perpendicular lead out is going to come straight off the part and then go home. So I'm actually okay with that. And then finally, the advanced feed rates, where we can convert our rapids to feeds, where we convert G00s in the code to G01s in the code, and then you're able to actually enter in your rapid feed. Right here, you have your lead in and lead out feed rate percentages. These are a percentage of your cutting feed rate, and this is just for lead ins and lead outs. When we're all done, we can hit compute. And then when the toolpath finishes calculating, we can see there is the front path right there taking off that facing material. So now I'm just going to right click on the feature and say blank on blank toolpath, and then I like to just shrink it up. Next, I'm going to go ahead and do the drill. And what's cool about the drilling in here is I don't actually have to pick geometry, because there's only one position I could drill on a lathe, and it's right down the center. So I'm going to say lathe hole, and I'm going to select my geometry, and then I'm just going to go in and try and pick the inside wall here, or I could just pick the circular edge right there and hit OK. From there, I can hit next, and we'll see that our clearance plane set to 1 inch, our rapid plane set to 200, our feed plane set to 100. Now right here, I get to just type in the diameter. So I'm going to say 0.25. The top of feature is going to be at 0, but we got to remember that 100 thousandths is in front of it. So 0 is actually where our origin's at. right where we have that little coordinate system. So 0 is the front face of the part. The facing took off an extra 100 thousandths that we're not accounting for anymore. So top of feature is going to be 0. The total depth, I'm just going to say 0.75. And then it is a blind hole. I don't want it to go all the way through the part. So from here, I'm just going to hit next. Right here, I get to choose either a lathe center drill, lathe hole, lathe bore, or lathe ream. I'm going to go with the lathe hole, which gives me a center drill and a drill. And then I'll hit next again. For the posting, once again, we have the choice of separate moves or CAN cycles. And so I'm going to just leave it on CAN cycles for drilling. Most of the posts should have this one in it. So then I'll hit next again. Right here, we have our number 5 center drill as listed. We have our tool number, our spindle direction, as well as feeds and speeds. Now, again, when you're drilling, we can calculate feeds and speeds based on your material. So I'm just going to hit next. Right here for the parameters, we just have our total depth and then center diameter. We can tell it whether we want to do it as a single depth or pick, and then I'll hit next. Right here for the rapids, I'm just going to start from the default rapid approach and just go to the normal default rapid on exit. And then we get to our drill. So the drill, it picks our 1/4 inch drill, tool number 5 here. And we have our feeds and speeds once again. So I'll say next. The total depth, where we're going to get a full 1/4 inch wide cut, is going to be to 3/4 of an inch. The tip of the tool is not stopping when it gets there, though. The tip of the tool stops when it hits 0.8251. So that's going to be the overall depth. That's what you're going to see inside the code. And then from here, we get the choice of either doing it as a single depth, a peck, or a fast peck. And for the difference between pecking and fast pecking, if you go to run it and it doesn't let you fast peck, a lot of times it's because the post processor doesn't have that CAN cycle built into it yet. So I'm just going to say peck and then hit next again. We have our rapids. Again, I'm just going to use the defaults, and then I can hit compute. And that's just going to run the drill down the middle of the part. The next cut that I want to make is going to be doing this entire rough cut all the way down the part to take out all this material, and then we can come in and do the groove. So I'm going to start by blanking out the drilled hole. Then I'm going to right click on my machine setup 1 and go down to lathe turning. Now with lathe turning, my geometry is going to start right here at this front face, and then it's going to go all the way back. So I'm just going to pick every edge or wall all the way back. Now I'm even going to go and select all the grooves areas here, the whole thing right here, just all the way down. If you got to zoom in because some of this geometry is broken in a weird spot. I just want to go to there, then into here, up this wall over here, down that fillet, and then down that back side right there. So basically the whole thing. When I'm done, I can go ahead and hit OK, and then hit next. Right here, we have our rapid plane set to 200 thousandths. Right here, we get the choice of now setting the feature type. So if it's an OD cut, you're going to leave it on OD. If it's an ID cut, you're going to leave it on ID. This is going to start prepping the right orientation on the tools for you. And you could also tell it that it's specifically a front face or a back face cut. Now I'm going to say OD, region 1, and then right here we have undercuts. Now undercuts are grooves that are inside your geometry, so grooves that you've selected. And the way we can remove them is just by saying remove primary undercuts. Now remove primary undercuts will close off any turning grooves. So if you have a turn groove that's parallel to your Z-axis like we have here, if I say remove primaries, it's going to ignore that area. If I say remove secondary, that's going to remove face grooves from the geometry as well. In my case, I only have the primary undercuts, but if I leave both of them on, it's not going to hurt anything. Now, because this is my initial rough pass, I'm going to tell it to constrain to the stock. And then we also now have an option called from geometry, which is looking at the height of the geometry and then cutting what it can. We're going to use that more often when we do grooves because it's better for finishing. For the extension here, just like before, I could add a little distance onto it. So if I want to say, let's start an 1/8 inch before, we can go an 1/8 inch past. This is just going to extend the front cut and the back cut. Next, I then have my machining strategy. So this time I'm going to choose the rough and finish, but we also have the ability to set up pattern repeats or pattern repeats with a finish. So I'm going to go with the rough finish, which gives me a rough and a basic finish. Next again, I have my posting. Once again, separate moves or CAN cycles. Next again, I have my CNMG. So we'll see it's tool number 1. And so I'm just going to hit next. Now again, this is the exact same path we saw when we saw the facing toolpath. So you get the choice of standard or offset for your pattern. And then for your sorting, you get the choice of standard or zigzag. Right here, I'm just going to make sure to turn compensation on with collision detection and use the tool holder. Next, again, I have my parameters. Now this time I get to choose how much material I want to take off per pass, which I'm okay with 50 thou. This time I am going to leave material for the finish pass. I'm not going to mess with the rough allowance. I'm going to rough it in and then finish it with one other tool. And then right here, I'll tell it that I do want to overlap to a previous cut. So it's going to extend past where we cut and then lead out. Corner types I'll leave on round, and I'm not trimming any stock. So I'll say next again. Once again, for the rapids, I'm just going to use the defaults. So default rapid on the approach, default rapid on exit. Right here for the leads, a parallel lead in and an angled lead out will work just fine. We do have other choices though. You could start perpendicular, you can go horizontal, vertical, angle, or you could even do custom where you tell us the X and Z lead in and lead outs. So I'm going to say let's leave it on parallel for the beginning cut, and then go next again. For the advanced feed rates, we got the convert rapids to feeds and the lead in and lead out feed rate percentages. And then right here we get to our finish tool. So there is our VNMG. If we turn the holder on, we could see it right there. So I'm going to go next. Right here for the patterns, we have a choice of either going continuous, so we cut from the front face all the way back, or we can go with alternate. Alternate allows us to do vertical faces only where it back turns those areas, so you don't build up a big rat's nest in there. And you could also do your turn diameter. So this is now just doing the turn diameters only. And you also have the choice of doing both, so you can get them to work together. You can get it to turn the diameters only and then come back and do the faces vertically. In my case, though, I'm just going to leave it on continuous and say on with collision detection using the tool holder. Next, again, I have my parameters. So this is just how much I leave for another pass to clean up once again. We have our corner types as round or sharp, and then our trim to stock option. Next, again, we have our rapids. So I have a default rapid approach and a default rapid on exit. I'm going to leave them there. Once again, we have our leads. Just going to leave the defaults again and the advanced feed rates. When I'm done with this one, I can go ahead and hit compute. And what we'll see is I'm going to square up the screen with a Control 1 on the keyboard to make my view, and we'll see there is no toolpath going inside of that groove. So I'm going to right click on this feature and first just say blank on blank. And the reason I like to do that is now I can click on the rough specifically and say that's what the rough looks like, and that's what the finish is going to look like. I'm then going to right click on it and say rename. And I'm just going to say OD rough finish. So I know that it's done. And then I'm going to go ahead and shrink it up. And then I'm going to right click on machine setup 1 and go down to Lathe Groove. Now Lathe Groove is pretty straightforward. We're just going to pick all the geometry that includes the grooves. So I'm not just going to pick the floor and the 2 walls for the groove. If I'm going to use that finish tool to clean up these chamfers as well, I'm going to go ahead and pick those chamfers. So I'm going to pick those 2 right there. And then I could go ahead and just hit OK. Next, I then have my feature where I have my OD, so it knows it's an OD groove. It's from region 1. And then I'm not going to rotate it. But if you wanted to set up any custom angled grooves, you could set up a tool that matches at that angle. That way it treats it just like a standard groove. Now, so my toolpath doesn't start all the way up here and try and cut that groove, if I leave it on from stock, that's what's going to happen. If I say from geometry, it's going to start at the height of my geometry. So right up here, and then it's going to cut in. Now for this one, I'm not going to add any extensions. The leads are going to take care of that just fine for me. So I'm going to hit next. Right here, we get a choice of doing a groove rough and a groove rough and finish. So I have the groove rough and groove finish. I'll just hit next. Right here for posting, again, separate moves or CAD cycles. Next, I get to my grooving tool. So this is my 1/8 inch wide 64th rad grooving tool. If I turn on my holder, I can see there it is right there. And then down here is the tool number, spindle direction, and feeds and speeds. Next, I then have my patterns. Now with this one, I get the choice of either doing a standard or a single pass. I also can use a zigzag if I'm not using a CAD cycle. So if I go back to separate moves and go to patterns, I can use a zigzag now. So a standard is just going to be your standard groove. It's going to cut in, work its way across. Now the sorting down below tells us what order this is going to go in. So standard is going to start here. It's going to do 1, 2, 3, 4, 5. Center out is going to start in the center and work its way out from there. So we have 1, 2, 3, and then back to the other side for 4 and 5. Center out alternate's just going to flip-flop that. And then you have skip, where we're going to cut one, we're going to skip an area, we're going to cut the next, skip an area, cut the next, and then it's going to come back and cut the areas that we skipped over. The single pass option lets us choose if we want to use the center, the beginning, or the end of the tool, just depending on where our touch off location is, to just have a tool press in and cut a groove. So if you have a custom shaped tool that just presses in, cuts whatever shape you need, and then leaves, the single pass is going to be best. And you do also have a zigzag option, so you could feed your way in and cut down the part. I'm going to go with a standard pattern with a standard sort. I'm going to use the tool holder for collision checking just in case my holder or the stick out on here is not long enough. And then I'll go next. Right here for the parameters, I have a step over amount. So my tool's an 1/8 inch wide. I'm going to go with a 1/16 inch step over. I'm not going to leave any rough allowance, and I'm not doing any sort of semi-finishing. I'm going to finish on my finish pass. This is how much material I'm leaving for the finish tool to clean up. And if you're working with some grooves that are a bit deeper, you can even set up multiple depths and tell us what the depth of cut is before we make another pass to try and work our way in there. Down here, you have a choice of processing by area or by level. By area means it's going to try and finish an area before moving on to another that has a different level. And by level is going to take everything down at the same level, even if it's got a rapid to get to another position. So I'm going to go by area. And then we have our sorting is either one way or zigzag. Again, this is going to come more into play when you're doing these multiple depths and multiple passes. Right here, we have the choice of using a pecking option. So we can tell it what the first peck amount is. We can tell it what the peck increment after that is. We can tell it where the clearance is. And we can tell it where the peck retract amount is. I'm not going to peck this one out. I don't have another model that shows me where to cut, so I'm not going to trim to stock. Next, again, we have our rapids. So we have our default rapid approach and exit. So I'm going to say next. For the leads, just parallel. I want it to start above a little bit, and I want it to cut, and when it leads out, just cut a little bit extra if it needs to. Next, I have my advanced feed rates. Again, convert rapids to feeds, lead in and lead out feed rate percentages. And then we have our groove finish. So same tool, you'll see it's tool number 3. For the patterns on this one, we have a choice of doing force down cutting, meaning we start on both sides of the groove, we cut to the center, and then we pick the tool up and cut back to the other side from the other side. Right here we have our overlap amount. That's how much these two passes overlap into each other. Or we have a choice of just doing a basic finish. Plunge the tool in, cut across the groove, and leave. I'm going to go ahead and use just the basic finish, and I'm going to have the system compensation on with collision detection using the tool holder. Next, again, I have my parameters where, just like the old finish pass, I set up my allowance, corner type, and bounds. And then next we have our rapids. So we have our default rapid approach and default rapid on exit. Our leads, once again, I'll just go with parallel. It's going to be parallel off the chamfers that I created. And then finally, the advanced feed rates. When I'm all done and I can't hit next anymore, I'll just hit compute. And there is our groove. Now, after I finish up the groove, I'm just going to right click on it, say rename. I'm just going to call it OD Groove, just so I know exactly what it is. Then I'm going to right click on it and blank it out. Now, for the most part, this part is done. We've done the turn, we've done the face, we've done the groove, we've done the holes. The only thing left is to go and do a cutoff. So with the cutoff, we right click on machine setup, we go down to lathe cutoff, and we say select geometry. Now what I'm going to do is I'm just going to tell it to pick right here at this point so it knows where I want to cut to. I'm going to hit OK, and then I'm going to hit next. Now right here we have our rapid plane, our feature type, and we're going to tell it we want to machine from the stock. So we'll say next again. For the cutoff, it's the only option you get when you're using a cutoff. So I'll say next again. Right here, separate moves or canned cycles. Next again, we have our cutoff tool. So there it is, just like that. Hopefully we have enough length to reach. We won't see the exact length in here. We'd actually have to go into the holder preferences and find it in there. But all this looks good. I'm going to use the constant surface speed, tool number 6. Spindle direction is clockwise, and coolant's going to be flood. Next, I have my parameters. So for my cutoff in Z, that's a measurement from this coordinate system here, however far back we want to go. In this case, it's going to be 3 inches. So I'm going to say -3. For the X, if this was a positive number, I'd be leaving material above the center point. So if I said X 0.5, this is going to do a cutoff not in the center, but a 1/2 inch above the center. So in my case, I want to leave X at 0, and then I'm going to leave the retract amount at 0. We also have the ability to add a corner break. So you could say off, which is going to leave a sharp corner. We could say give us a chamfer or give us a fillet on the back edge. I'm just going to go with off because this part's sharp on the back corner. We also have the ability to do pecking. Just like with the groove, we have our first peck amount, our increment after, and then our peck increment, as well as a peck retract. And finally, we have our rapids, which is the same rapids as always. So I have my default on approach and default on exit. And when I'm all done, I can hit compute. And the path is just going to run right down there to the back side of the part. Now, the big thing here is if I had a point drawn out here, if I went and put a point on this surface, that would be a lot better for the cutoff because I could actually pick that end point. If I don't pick a point, I have to know the depth and where it needs to be cut off at. So when it's all done, I'm just going to go up to the simulation. We can see what it's going to look like when it simulates. And then when the simulation launches, we could go ahead and say run. And you might want to play with your simulation speed just so it doesn't run too fast. We've already done the face. Then we're going to go turn the OD, drill the holes, finish, and there is our cutoff for the entire part. So now if I go in and I turn on my workpiece, I can get a comparison between the part that I just created and the part that I cut. What I'm looking for is these areas where we see both white and blue because that's an area where I have a pretty decent finish. When I'm all done, I can just close out of the simulation using this X right here or the exit simulation button up at the top. And then when it's time to generate the code, we can just right click on the turning job here. First thing to check on would be the machining order. Make sure this is all running in the order you want, especially the way you saw it in the simulation. If you needed to change it, you could. I could say, let's go by individual feature and then hit OK, and that's going to change it around for me. When I'm all done, I can hit OK, and then right click on my turning job and say post. And this is going to generate the code that I could then bring out to the machine or bring into the NC editor to make modifications to. And that concludes the video on using BobCAM for SOLIDWORKS for turning.